मित्रांनो, मागच्या काही व्हिडिओ लेक्चर्स पासून आपण केमिस्ट्रीच्या दुसऱ्या चॅप्टरला सुरुवात केली होती आणि दुसऱ्या चॅप्टरचं नाव म्हणजे इलेक्ट्रोकेमिस्ट्री। विद्यार्थी मित्रांनो, हा चॅप्टर बघत असताना आपण या अगोदर काही पॉइंट्स पाहिलेले आहेत। तेच पॉइंट थोडक्यात आपण पुन्हा एकदा रिवाइज करूया आणि मग आजच्या लेक्चरला सुरुवात करूया। मागच्या काही लेक्चरमधून आपण पाहिलेले पॉइंट्स म्हणजे व्हॉट इज मीन बाय इलेक्ट्रोकेमिस्ट्री। या चॅप्टरची सुरुवात होत असताना इलेक्ट्रोकेमिस्ट्री म्हणजे काय हे आपण पाहिलेले आहे। त्यानंतर व्हॉट इज मीन बाय इलेक्ट्रोलाइट्स अँड इट्स डिफरंट टाइप्स। इलेक्ट्रोलाइट म्हणजे काय आणि त्याचे वेगवेगळे प्रकार कोणते हे सुद्धा आपण पाहिलेले आहे। त्यानंतर आपण ही जी इलेक्ट्रोकेमिस्ट्री ब्रांच आहे ती ब्रांच आपल्याला आपल्या रोजच्या जीवनामध्ये उपयोगी पडते का, त्याचे उपयोग आपल्याला जाणवतात का, हेच पाहण्यासाठी आपण जनरल ॲप्लिकेशन्स ऑफ इलेक्ट्रोकेमिस्ट्री हा सुद्धा कन्सेप्ट बघितलेला आहे। आणि मागच्या व्हिडिओ लेक्चरमध्ये आपण शेवटचा कन्सेप्ट म्हणजेच द डिफरन्स बिटवीन स्ट्रॉंग इलेक्ट्रोलाइट्स अँड वीक इलेक्ट्रोलाइट्स हे बघितलेलं आहे। सो आफ्टर ऑल these points we will going to start our today's lecture. So in our today's lecture or in our today's discussion we will going to start very important concept, and that concept is nothing but the Faraday's laws. Faraday's laws. Now the Faraday is nothing but it is a name of scientist. Faraday is a very famous scientist, and it is basically he belongs from the British or from English scientist community, but he put its great efforts in electrochemistry branch, and he put forwarded two different types of laws on the basis of electrolysis study, and these two laws are well famous in chemistry. That's why we will going to study here Faraday's laws, and these laws comes into two different forms, and therefore we will going to call it as Faraday's first law and Faraday's second law. Faraday's first law, obviously both the laws are comes under the heading of electrolysis process. So Faraday's first law and Faraday's second law, out of that at first we will going to see Faraday's first law. Before going to start this concept, we must know that what is meant by the electrolysis process. The electrolysis process, we will going to just draw a simple diagram of beaker, and in this beaker the electrolytic solution will be present. These dots are nothing but these are the electrolytic solution, and inside this beaker the electrolytes in the forms of electrodes also present, and these two electrodes are connected by using electrical wires, and there will be a battery connected to both the electrodes. The charges are always present, here positive charge and here negative charge. We will going to call that as anode, and here cathode. This one is nothing but this is an electrolytic solution. These are nothing but this one is electrode and these all means electrolysis process. We know the what is meant by electrode, anode, cathode and electrolytic solution. After knowing all these things, we will going to study the statement of Faraday's first law statement. According to Faraday's first law, the mass of substance or the weight of substance or the amount of substance liberated on or at a particular electrode during the electrolysis process. This is nothing but, this one is electrolysis process, this is nothing but state of electrolysis process, these one are the electrode, this one is nothing but electrolytic solution. According to statement, the amount of substance or the weight of substance, we will going to consider the notations for the weight at W. During the electrolysis process, it is directly proportional to the quantity of electricity passed through the electrolyte. Quantity of electricity passed through the electrolyte. Here, the electricity is passed from this way. Here, the electricity passed from this way. Means, for the electricity, we will going to give one single letter like Q. Q is nothing but it is an electricity. Means, according to Faraday's first law, the amount of substance or the weight of substance during the electrolytic process is directly proportional to the quantity of electricity passed through that particular electrolyte. This statement is a standard statement of Faraday's first law of electrolysis. The mass of substance or the amount of substance or gas liberated at particular electrode during the process of electrolysis, it is directly proportional to the quantity of electricity passed through that particular electrode. Now, we know that Q is nothing but quantity of electricity, but Q is nothing but C multiplied by T. C multiplied by T. Now again, question arises that what is meant by C? So C is nothing but current and T is nothing but time. So that current is measured in ampere and time is measured in second. Now W directly proportional to Q. To remove this proportionality sign, we will going to consider some constant, and this constant here we will going to take Z. Z is nothing but electrochemical equivalent. Electrochemical equivalent. Now put the value of this Q in above equation, then we will going to observe in this way. I am just rough this portion, then we will going to well observe. Here W is equal to Z multiplied by C multiplied by T. C multiplied by T. Now, if the value of C is equal to 1 and value of T is equal to 1, then W is equal to Z, and this one is nothing but the Faraday's first law of electrolysis. According to Faraday, the amount of substance or the weight of substance deposited or liberated on the particular electrode during the electrolysis process, it is directly proportional to the electrochemical equivalent. म्हणजेच फॅराडे सायंटिस्टला असं सांगायचं होतं, ज्यावेळी तुम्ही इलेक्ट्रोलायसिस प्रोसेस करता त्यावेळेस इलेक्ट्रोलायटिक सोल्युशन मधली जो काही सबस्टन्स असेल, इलेक्ट्रोलाइट असेल, तो इलेक्ट्रोडच्या सरफेसला डिपॉझिट होणार आहे आणि तो डिपॉझिट होणारा जो सबस्टन्स असेल या ठिकाणी तो डिपॉझिट होईल आणि तो डिपॉझिट होणारा जर सबस्टन्स कशावर डिपेंड असेल तर जेवढी क्वांटिटी ऑफ इलेक्ट्रिसिटी तुम्ही त्या इलेक्ट्रोडला पास कराल, प्रोव्हाइड कराल तेवढीच क्वांटिटी ऑफ किंवा तेवढाच वेट ऑफ सबस्टन्स तुम्हाला या इलेक्ट्रोड वरती डिपॉझिट झालेला दिसेल. या इलेक्ट्रोड वरती त्या सबस्टन्सचा लेयर तुम्हाला दिसेल. हेच आपल्याला फॅरेडे नावाच्या सायंटिस्टनं इलेक्ट्रोलायसिस कन्सेप्टचा अभ्यास केल्यानंतर दाखवून दिलं. आणि त्याच्या या अभ्यासानंतर आपल्याला इलेक्ट्रोकेमिस्ट्रीमध्ये अनेक प्रकारची नवीन नवीन बदल, नवीन नवीन संकल्पना मिळाल्या. आणि याच संकल्पना शक्य झाल्या कारण फॅरेडेने लावलेल्या पहिल्या लॉमुळे. त्यामुळं फॅरेडे फर्स्ट लॉ इज नथिंग बट, फर्स्ट स्टेटमेंट इज नथिंग बट the amount of substance or the weight of substance deposited on particular electrode during the electrolysis process is directly proportional to the quantity of electricity passed through that particular electrode. And finally, when we will going to put the values of Q, quantity of electricity, as C multiplied by T, then we will going to form final equation in the form of W is equal to Z, where the W is nothing but weight of substance deposited on particular electrode during electrolysis process, while Z is nothing but electrochemical equivalent. This is nothing but Faraday's first law. विद्यार्थी मित्रांनो, या लॉ मध्ये आपल्याला सांगितलेले दोनच इक्वेशन परीक्षेच्या दृष्टिकोनातून महत्त्वाचे आहेत. पहिला म्हणजे W is directly proportional to Q आणि दुसरा म्हणजे W is equal to Z. means weight of substance deposited on particular electrode during the electrolysis process is directly proportional to the quantity of electricity passed through that particular electrolyte. And second one is weight of substance deposited on particular electrode during electrolysis process is equal to their electrochemical equivalent. This is all about the Faraday's first law of electrolysis. विद्यार्थी मित्रांनो, I hope this law we will going to well understand. If you have any doubt regarding to this concept, then you should definitely ask me. So in our today's lecture we will going to stop here. In next lecture we will going to start very important and related to same electrolysis concept, second law of Faraday, and this law is very important as concerned to our examination, so that in next lecture we will going to see the Faraday's second law. I hope all these parts you will going to well listen, well observe and well understand. Thank you very much.